Welcome back, pre-algebra. We're in lesson 30, and we're going to talk about adding and subtracting fractions today that have unequal denominators. So we know that we can add fractions that have the same denominator. So if I have, let's say I have some bricks here, right? And I have 1, 2, that one's not very messy or neat, is it? It's kind of messy. 3, 4, 5. Okay, I have those bricks. Let me copy those because that's pretty even. I'm going to take those. And let's just say that I have 1/5 of this set of blocks. So that would be one of those 5 right here, just like that, right? So now, if it will ever paste for me, it's thinking. I'll give it just a second. It takes it a minute. That is not what I wanted it to copy. Okay, wrong thing. So now let me get rid of that. All right, so let's just copy this one. I'm going to copy this. Copy, there we go. Now I can paste that. There we go. All right, so now I want to add 3/5, right, to this 1/5. So that's going to be 1, 2, 3, right? So if I have 1/5 and I have 3/5, then I know they're the same size. They're the same value. They fit in the same collection, right? Because they are the same number of parts. So I can, let me paste again. I can do that mathematically and visually, and I can say 1 plus 1, 2, 3. That's the same as 4/5. 1, 2, 3, 4 out of 5 pieces. That's what I have, is 4/5. That's pretty straightforward. We know that the denominator just stays the same all the way across, and we're just telling it how many parts of that whole we have. I have 1 out of those 5 slots, right? I have 3 out of those 5. So 1 out of 5 and 3 out of 5 gives me 4 out of 5. That's pretty straightforward. What if we have different denominators? What if we have different denominators? How do we handle that? Okay, well, let's look and see. Let me draw us a box here. And there are 2 parts to this box. We're just going to pretend they're exactly equal. I'm going to copy this. And I'm going to paste it over here. All right. So let's say that I have 1 out of 2, right? I have 1 out of 2. And over here, I have 1 out of 4. How on earth am I going to add these 2 together? There's 2 parts here and there's 4 parts here. Well, if you notice, whenever I converted this into 4 pieces, I just cut the 2 pieces that are already there in half. I basically multiplied the number of pieces by 2. So why can't I do the same thing to the original? Can I go backwards and just draw a line here I can. And guess what? Now I can rewrite this as 2 out of 4 pieces. Now, isn't that the same denominator? It is. And it's the same number of pieces. So let me do that to our final result. If I have 2 out of 4 pieces in the first part, and then I have another one, well, isn't that 3 out of 4 pieces? It is. And we did that by adjusting the denominator or the number of pieces in the set so that they had the same number. I figured out what they had in common to do that, and that was looking at just the set itself and figuring out how can I turn 2 into 4, and I did that by multiplying by 2. And the way we do that mathematically is by looking for factors. We look at the factors of both denominators and we ask ourselves, can we find a common number between the two of these, a common factor that will allow us to just multiply, right? Or divide to find the same, when we divide, we're reducing a fraction down to its lowest form, or to a lower form so that the denominators are the same. When we multiply, we're increasing the size of the fraction so that the denominators can match up. Okay, and there are reasons for doing both of those. All right, so for instance, with this one, the reason that we multiplied this one by cutting it in half and making 4 out of 2, we multiplied it by 2, is because we can't reduce 1. We couldn't turn this, we couldn't divide this by 2 because 1 is a prime number. We can't divide 1 by any other number. It has to stay. We don't want to have a decimal in our fraction. That's kind of crazy. We want to keep it just a whole number on top and a whole number on the bottom because then we can understand that. So that's what we do. We have a reason. We can take this back down to 1/2. It means the same thing. Visually, it's exactly half, but the commonality here, we'd rather have it in 4s because this is a 1 and we can't bring this down any smaller. 1 is the smallest whole number, that has any value. All right, so let's move on to adding and subtracting with unequal denominators. There are some rules that we have to follow. And I'm just going to scroll over and I'm going to write those rules right here. 1. First rule. We're going to find the least common denominator of fractions. So we call that, we're going to find the least common denominator, the LCD. And that's often called the least common multiple too. The least common denominator is what we're going to find. Find the LCD. Number 2, we're going to write all fractions with the new denominator, which is the LCD. Step 3, we're going to find our new numerators. And number 4, then we'll do the calculation. We will solve it. All right, so let's try that out. Let's get a practice problem here. So here I have 5 over 11. This is 30.1. And I am subtracting 1 over 5. 11 and 5 have no factors in common. So what we have to do in order to find the least common denominator is to find the least common multiple. So you remember how to do that. What we do is we find the least common multiple from the factors of 11. And the only factors of 11 are 1 and 11. The only factors of 5 are 1 and 5. So we have a common factor of 1. So we have 1 times 11 times 5. That's all we can do. That's it, because those are prime numbers. So we're going to multiply each fraction by the opposite denominator. So that is going to be 5 times 5, or actually it's just going to look like this. 5 times 11, or 5 over 11 times 5 over 5, minus 1 over 5 times 11 over 11. And that ends up looking like, let me erase all this down here. That ends up looking like 5 times 5 is 25, and 11 times 5 is 55, minus 1 times 11 is 11, and 5 times 11 is 55. 25 minus 11 is going to be 14 over 55. Easy peasy. Most of the time, we're going to ask ourselves some simple questions in order to find the common denominator. And the first question we ask ourselves is, are the numbers prime? If the answer is yes, then step 2 is to multiply. If I can actually write multiply, we're going to multiply by the opposite denominator. Okay. Now, if only one of the numbers is prime and the other number doesn't have any common factors that we can reduce with, we do the same thing. We treat it like a prime number. So by that, here's what I mean. I mean that if we have a problem that looks like 1/2 plus 1/8. 2 is a factor of 8, right? But I can't do anything with 8 because this is prime. I can do something with this. I can multiply this by 4, but I can't change this. So I pretend this is prime, and I just adjust this one. All right, or what if my denominator here is 1/3? Well, 3 is prime, 8 is not prime, but 3 is not a factor of 8. I can't do anything. So even though 8 is not prime, I have to multiply this fraction by 8 and this whole fraction by 3 in order to solve it. Okay, so if one of your numbers is prime and it's not a factor of the other denominator, then you have to treat both numbers like they're prime and then just multiply by the opposite denominator. Then you can solve it. Okay, so let's look. Let me clear this. And listen, be sure if I'm going too fast to rewind, pause, take notes. All right, otherwise you're going to miss something. I can wait on the video right now. Not in real life. You know, I don't like to wait in real life, but you know, you can pause me as a video. I don't mind. I won't be able to tell the difference, quite honestly. So let's look at 30.2. Oh, this one has a bunch of numbers. We have 1/4 plus 5 over 9 plus 2 over 3. Goodness. So first of all, I'm going to try to look for factors. So the factors of 4 are 2 and 2. The factors of 9 are 3 and 3. Factors of 3, it's 3 and 1 because it's a prime number. I can't do anything else with that. But 9 has a common factor, right? So it's 3 times 3. So that tells me this just has a factor of 3. So if I take this other factor and multiply this one, then they'll both have a denominator of 9. So that's what I'm going to do. I'm going to multiply this one by 3 over 3. And that'll at least get these two the same. So now I have 1 over 4 plus 5 over 9 plus 3 times 2 is 6. 3 times 3 is 9. Okay, so now 2 match. So that's awesome. So now I'm making some headway. But now I'm going to look at these two different denominators again and remind myself of their factors. 2 and 2 and 3 and 3. They do not have any factors in common. So I'm going to have to multiply by the other denominator. So what that means is I'm going to have to say 1 over 4 times this denominator. So 9 over 9 plus 5 over 9 times this denominator. So 4 over 4 plus 6 over 9 times that other denominator, which would be 4 over 4. So now I can multiply and I can rewrite it. So 1 times 9 is 9 and 4 times 9 is 36 plus 5 times 4 is 20, 9 times 4 is 36 plus 6 times 4 is 24, 9 times 4 is 36. Now they all have the same denominator. So now I can easily do the math. 9 plus 20 is 29. 29 plus 24 is going to be 53. 53 over 36. And that is an improper fraction. I'm fine with the improper fraction. You do not have to give it to me as a mixed number. If you wanted to give it to me as a mixed number, you could put in 1 and 17 over 36. And as long as that's the only part of the answer, it's just the fraction, I'll take either one. The system will automatically calculate that for you. All right. I prefer this one. That's what I'd like to see. I would like to see the improper fraction. I would like for you to get into the habit of leaving it as an improper fraction, okay? That is going to be important for you as you go further into the higher algebras. The improper fractions are going to be the proper response. So let's start practicing that. Don't turn it into a mixed number. And if your mama's standing there and she's fussing at you, saying, it needs to be a mixed number. Okay. Obey your mama. But type in the system this one. Okay? That's what I need. All right. That is all we have for lesson 30. So I will see you all in lesson 31.